We're back
Whoa, hey!
with sound and everything, I hope.
Yeah.
All right, so next up, we're going to pull in our first speaker of the day. We're going to do some machine learning,
Please.
which is all the rage. So, Brendan, are you with us?
I'm doing hand signals for a reason, man.
I can't. Sorry, dude, there's a light in the way. Hey, Brendan.
Hey, how's it going?
Good, how are you doing?
I'm doing great.
So, you are our first speaker for Saturday. How's that?
Yeah, I'm excited. I hope people like my talk. Looking forward to the questions in the Twitch chat and on Discord. My username's Death Caliber, so if you want to hit me up on there with any questions, or if you just want to, talk in Twitch, whatever. So
Awesome.
I hope you guys like my talk.
You want to give a quick little blurb about yourself?
I kind of do it in the video already, but just a little bit more, I guess. I'm based out of Cleveland, Ohio. I'm a senior software engineer. I also work on this little startup doing machine learning for games. So we're looking definitely for people to partner with us in the game dev community to help bring some more of this technology to other games. So if you're a game developer out there, start thinking like, how could I use machine learning in my game?
Awesome. Well, let's rock your talk then, and we'll catch you in a little bit here for some Q&A. Double.
Sounds good. Hello, I'm Brendan Mulcahy, and this is my talk, Machine Learning for Games. This is being presented originally as part of GDEX 2020, so if you're watching live at GDEX, I hope you're having a great day so far, and I hope you'll stick around and learn something about machine learning. You may not realize it, but video game AI sucks. There's so many problems with AI today. Machine learning is part of the solution. We can use it to make our AIs much more fun and exciting. However, getting machine learning working in your games is challenging, especially if you've never done anything with machine learning before. What I'm going to show you, though, through our demo, is that it's possible to make games that are much more fun and exciting by using machine learning. Before I get into the talk, a little bit about me. About a year ago, I co-founded a startup called Strife AI, which is looking to do two things. One, we're bringing machine learning to the video game industry by developing a machine learning library that is tailored specifically with game developers in mind. You don't need a PhD in order to do machine learning if you have the right tools. And secondly, we're producing games that use our machine learning library in order to showcase how the technology can be used to make more fun and engaging characters. Besides that, about 2 years ago, I co-founded a nonprofit called Cleveland AI, which is educating software developers in the Cleveland area how they can use machine learning in their day jobs. Video game AI sucks. It doesn't matter whether the AI is your ally, or if it's your enemy, or if it's just random NPCs you meet out in the street. No matter where AI is, there's always some type of problem with it. Allied AIs in games are typically terrible. Picture you're playing your favorite JRPG. Usually you're the DPS and you have a healer and a tank with you. For some reason, the healers never heal you when you need to be healed, and the tank never gets aggro when you need it to get aggro. It's super frustrating. And what's strange is, while you're going on this huge 60-hour-long journey with your companions, you'll be learning a ton, but the AI won't be learning anything. They might be getting better healing spells and better damage dealing spells, but they never actually get more intelligent. If they were terrible at healing you at the beginning of the game, they'll still be terrible at the end of the game. This is super frustrating because you're getting better. Why aren't your companions getting better? I think we can solve this problem by using machine learning. Secondly, enemy AIs are often super challenging or way too easy, depending on your skill and experience with the particular game. A game like Dark Souls is known to be challenging. However, there aren't a ton of ways that you can make the AIs a lot smarter or dumber during a game. Typically, game designers are left with tweaking or balancing the game based on removing or adding characters to particular battles, rather than dumbing down the AI or making it smarter. Often, taken to the extreme, the AIs have to cheat in the games in order to even be good. For example, in Civilization, when you play in the deity difficulty, the AI characters get more gold and resources than you, despite doing the same things. This is super frustrating for me, because if I'm beaten by the AI, I want to be beaten because I was outsmarted and outplayed, rather than because I was outcheated. The other thing is that characters in these games are often scripted to have very particular patterns that they use during combat. While this is great in the beginning, eventually when you master their moveset, it tends to get super boring. You can see how maybe machine learning could be used to break the characters out of their scripted patterns. Finally, if you engage random NPCs in a game like Oblivion, you'll find that the majority of them aren't all that interesting. They typically follow a set loop and live the same day over and over again. It reminds me a lot of the HBO show Westworld. We need some type of technology to break the AI out of its loop. So video game AI sucks, no matter if it's your ally, it's your enemy, or it's just a random neutral NPC. So what can game developers do? Well, there's already one solution that many people lean on, which is multiplayer. Instead of having to make characters smarter, what if we just replace the characters with real people? Well, there's various problems with this. One is that as a game designer, you want to control the experience that players are getting. However, you can't control the players of your game. So you can get something like this humorous situation where one player will say, I think it's your fault just because otherwise it's my fault, and I don't like that. Players will often act mean to other players because they don't want to own up to their own mistakes. The more important issue, and the one that's much closer to my heart, is that sometimes players don't have overlapping schedules with their friends. I'm a new father, and I often have to take care of my son at the times when my friends are playing games online. So I'm stuck playing single player games, and I would like to play single player games where the characters are fun, exciting, and they learn and change as I learn and change. So, machine learning. Enough said, am I right? It's the solution to all of our problems. Well, joking aside, let's dig in a little bit more into the details to figure out how machine learning can be used in games. It's big brain time. So, it's a super interesting time to get into machine learning. There are many different ways you can use it, depending on if you're interested in graphics or gameplay, and all kinds of different things. With many older games, you can use a neural network in order to upscale the lower resolution textures into something that'll fit onto a 4K display. This is an exciting way that we can take old games and make them look nicer without having to put in a ton of development time. Another thing that I've always found cool is you go watch on YouTube various videos of older games you used to like and see how a neural network can learn to play them. And then finally, there are huge game studios like OpenAI that are using games in order to better perfect the machine learning algorithms. There's so much cool stuff going on in machine learning, and I want to convince you that gameplay is the one thing we should be looking into. So if you go look at games on the market today, you'll often find that while some of them seem to have machine learning, they often have what I'm going to call fake machine learning. In Smash Bros, you can get these characters called amiibos, and you can train them to play similar to how you play. If you kick a bunch, they'll kick a bunch. If you punch, they'll learn to punch. But what they're capable of learning is pretty limited. If you do some intricate combo where you always kick, then punch, and then uppercut, the AI can't learn to do that because it's very limited in how it models your behavior. It basically just learns the frequencies at which you do certain actions. The other thing is there are games like While True Learn, which, don't get me wrong, are super fun and exciting. They claim to have machine learning, but within the actual game, there's no machine learning going on. It's basically a glorified decision tree, and you're solving puzzles. Again, it's fun, but I'm a little disappointed that there's no actual machine learning going on. So, can we go further? Can we actually train an AI during a game? Most games that we've seen so far, and most things that people have attempted, involve training an AI model before actually playing the game. So while we get the cool output of the AI, which is the model, we never actually get to see learning happening during a game. The other thing too is that these AI models are often only trained from human data during the bootstrapping process at the beginning of training. So I think we can do better. We could train AI characters using human data from start to finish. But before we get into that, let's take a step back and review neural networks, which is the cutting edge technology today. So neural networks are kind of like a magical black box where you put floating numbers in one side and you get floating point numbers out of the other side. And by running a learning algorithm on the neural network, you're able to update it so that the floating point numbers out are better than the ones that went in. You can't explain that. Well, actually you can. If you peel back the lid of the box and you take a look at what's going on inside, a neural network is modeled to work similarly to how the human brain works. There are various layers connected together with connections, and what happens is we end up training the network by updating the connections between these layers. So that's an interesting way to understand how the machine learning model is kind of working, but how does it actually work in its implementation? Well, it turns out that under the hood, a neural network is basically a bunch of fancy multiplication of matrices. You have matrices for weights, which is the learnable part of the network, and then you have matrices for the input that get multiplied together until you get a matrice for the output. Then you use those floating point numbers to determine to take certain actions in your game. The way the training actually works is we have a target set of floating point numbers, maybe the human's play data, and then we compare it to what the neural network predicted, and we measure the distance between those two vectors. By using a little bit of calculus, we can follow the gradients and update the weights of our matrix in order to get the predicted output of the neural network closer to the target output. That's what we call learning. So besides a neural network, you also need a learning system. And I'm going to go over 3 different systems you can use in games. There are reinforcement learning, preference learning, and imitation learning. Reinforcement learning basically views the game as 2 different things. One is the agent, which contains the machine learning system, and the other is the environment, which is basically everything that's not the agent. This can include the physical game world and also all of the other characters in the game world. The agent takes actions in the environment, and then the environment will update its state based on what the agent did. It'll also return a reward to the agent, letting the agent know if it did something good or bad. For example, let's look at a game I worked on. I built a really simple simulation game where there's little robots on a platform. If the robot falls into the hole in the middle of the platform, then it'll get a negative reward because it died. If the robot knocks the ball into the hole in the ground, then it'll get a positive reward for scoring a basket. By looking at these negative and positive rewards, even though it's taking random actions in the world, it's able to make the connections between which of its actions led to a positive reward and which of its actions led to a negative reward. by reinforcing the positive behavior, we end up getting interesting looking actions. So what are the problems with reinforcement learning from a player's perspective? Well, as you can see, my game world has roughly 32 of these characters who are all sharing a collective intelligence. And this simulation took roughly 2 hours of random actions until the bots were able to play the game correctly. So 2 hours times 32 agents basically means that we had to train for 64 hours, even in the simplest of game worlds. This is extremely slow. A player is not going to wait 60 hours to see something interesting happen. They want to see something happening in 30 seconds or a couple minutes at most. The other thing is that this game world isn't very interactive. Every single player is going to see the exact same end behavior, and they have nothing to do in between. They end up all having the exact same experience, so no player is going to have something more enjoyable for them. So, can we do better? Well, if we take a look at the reinforcement learning problem, we can make it a game by allowing players to change the rewards. Let's say in my game, I think it's funny to see the bots die, so I'll change the reward for the bot falling into the hole in the ground to a positive reward. Now, when the bot accidentally falls into the hole, that behavior will get reinforced and it'll learn to do that more and more. So that's starting to kind of sound like a game. OpenAI has a paper called Learning from Human Preferences where they dig into this further. They basically have a game with a leg with a foot, and it's supposed to hop along the game world and get as far as it can from the starting location. But players of this game are able to train any behavior by changing the rewards. What the simulation does is it'll take the existing character and then generate 2 different versions of it and show them side by side, similar to maybe like a Tinder application of a sort, where you pick left or right, which one looks more like the desired behavior that you want. In this case, the players of the game were prompted to attempt to get the leg to do a backflip. So they would look at 2 random kind of twitches and figure out which one of those looked more like a backflip. The average player of this game was able to get a backflip working in only 900 actions, which if you're clicking pretty quickly, that's not too bad, especially if you see the learning happening every single time you take a click. So this is really exciting. It's starting to look like we have potential to make a game here. So how can we do even better? What we could use is imitation learning. In imitation learning, the bot is basically a student learning from a teacher, and in this case, we'll let the player be a teacher. The player will give demonstrations of how to play the game, and the AI system will learn to play as the player does. So how does playing a game work from a human's perspective? Well, basically, you look at the screen with your eyes, and you ascertain the state of the game. Then you take actions on a controller in order to update the state of the game into some type of desired state. Typically, you want to win. What we then do is we take the state of the game at the same moment that you're taking actions on the controller, and we feed that state to the AI system along with the action that you took. After 30 seconds to a couple minutes of playtime, we're able to train the AI to behave exactly how you do in the game world. Once the AI system is fully trained, we can essentially hand it a copy of the controller, and now it can play alongside you. We give it control of one character and you play someone maybe on its team. You can imagine how fun it would be to, in let's say a JRPG, play each of the different characters how you want them to play, basically giving a demonstration, and then saving the weights of the neural network so that you can reload these characters at a later time. You could play as both the cleric and the rogue and the wizard and the warrior, and then play alongside the copies of yourself. That sounds really fun and exciting. So there's definitely great promise in using imitation learning. However, machine learning is really challenging, even if you know what you're trying to do. Like I said, my startup has been running for about a year, and we had to build a variety of games over that year to figure out how machine learning can actually work. So I have a number of lessons I want to take you through and show you some potential pitfalls that you could run into. The first thing is, we built a game where you're defending a castle from enemy invaders, and we built this whole game in C# using TensorFlow.net. While this library is really easy to get started with, you run into a ton of problems with the garbage collector. All those matrices and all that math ends up generating a lot of garbage. And because we didn't write the library, we don't have a lot of control to go pre-allocate that memory. So at this point, in order to get rid of the stuttering caused by the garbage collector, we would either have to write our own machine learning library in C#, or we could switch to a language like C++, where we have more fine-tuned control over the memory, and there's already existing libraries that don't have this garbage collection problem. Secondly, you have to design your game with machine learning in mind. You can't really take an existing game, just slap machine learning on it, and hope that it's more fun. For example, if your game world has huge open spaces without a lot of variation, it's possible for the machine learning agents to get lost, even though a player would know where they're going. Imagine you as a human being stuck in a corn maze. Everything looks the same no matter which direction you're facing. There's just corn everywhere. The same thing kind of happens for the ML characters in our game when they're in big open areas. All of their input looks relatively the same no matter where they move, so they can get stuck in loops and get completely lost, unless you extend the memory of the character all the way back to the beginning of the game, which tends to not be very feasible from a performance perspective. So using these lessons, we were able to make an MVP of our game, or a minimum viable product, that showed how machine learning could be used. We built a sort of infinite runner, where you have to jump across spikes and different chasms, and try not to fall. And you're being followed by a character that looks and acts just like you, and learns how to play through the world from watching how you play through it. This was super exciting for us because it proved that the technology could work. However, our game wasn't super fun. What's the point of watching another character jump through the game world when it's more fun for you to jump through the game world yourself? You're starting to see that maybe machine learning and being an ally doesn't work so well together, at least in this sort of a game. So we ended up flipping that around. Our game Chaser, which is currently in Steam Early Access, you are an astronaut on a spaceship running from a rogue AI that has gotten out of the lab. It uses machine learning in order to copy all of your moves, whether you're jumping across gaps in the ground, or sliding through boxes, or avoiding various traps. The machine learning agent is watching, and it's getting better all the time. So I'm going to switch to a demo of our game, and I'll talk over it a little bit to show you how it works. Give me 1 second here as I bring up the video. Okay, so We have an idea for a campaign mode for this game, but we first implemented a sort of arcade mode in order to hit the ground running. In this game, the AI only learns how to play from you. It has no idea how to jump, and no idea how to do anything else in the game world. Because it's sort of an infinite runner, you're forced to run forward. Therefore, you're forced to perform jumps. From watching you perform these jumps, the machine learning agent is able to learn to play the game within seconds. So while I'm playing this game, because I already know how it works and I already know a lot about machine learning, I'm pretty good and I won't die that often. But this game is surprisingly hard because the agent is learning to copy everything you do. When you're performing jumps in the world, the agent receives basically a grid of your surrounding area, and it learns to connect the patterns between what is happening in the grid around your character and what actions you're taking. So as I'm jumping through this world, in the beginning I didn't break any of the boxes because I had wanted to try to avoid the bot and hoping that he would get stuck on a box. However, I'm starting to break the boxes now so that I can show you that the agent will also learn how to break the boxes. So then, as the game goes further, you're trying to escape into a spaceship that you docked to this space station, and you have to blow up these reactors in order to destroy the AI before it escapes out into the broader universe. But the bot is trying to beat you to your ship because if it can escape, then it can go on to live and take over the universe. You can see that we put a lot of thought into some of the level design by having various pathways through a level. One player can slide under all of the objectives, and another player can jump over all of the obstructions. And this will allow players to see that one agent is training separately from another agent. There's no canned behavior. Whatever you do is what the agent will do. As the game goes further, the AI gets better and slightly faster so that it'll eventually catch up to you. And we had to put in various obstructions in order to give players a way to get space between them and the robot. Those gates you just saw are a great obstruction that a player can take advantage of. As the game goes on, you can see that the agent is getting faster and smarter. In the first few reactor rooms, I hadn't even seen the robot as I was trying to disable the reactor. However, in this last room, the robot was right behind me, and he's going to keep getting closer and closer. The one thing that's super interesting that makes this game a lot different from anything else is that you have to think, what will the bot learn and what do you want it to learn? What are you going to keep in the back of your mind and try not to show the bot too early in the game? For example, if I don't want the bot to break through crates, I'll purposely jump over them and hope that it gets stuck on a crate and it doesn't know how to slide through it. However, later in the game, I might get into a tricky situation where the bot's right behind me and I need to break a box to escape. In crafting different scenarios where the player is forced to do various things, we can eventually give the agent everything it needs in order to learn to play successfully. So this is one of the later stages of the game, and you can see the bot is right on me. Typically, if I was playing correctly, I would have banked up some items so that I could get away from the bot in this sort of situation. Luckily, at this moment, I find a force field, and I use it to get a little bit of space between me and the bot. I really like this part. It shows that the bot jumps over that staircase of boxes without breaking through them, which is exactly what I had done. That's really cool and shows how the machine learning is actually doing what I'm doing. So I was trying to save my speed boost, but I should have used it because the bot catches me as I'm trying to disable this last reactor. So I hope this demo showcases how machine learning can be used to do something really exciting. So let's get back to my slides. The final thing, which I alluded to earlier, is that my company is producing a machine learning library that's tailored to game developers and what they're trying to do. It's easy to use and easy to understand. You don't have to have a PhD in order to play around, or to even build a game like ours. I don't have a PhD, I just have an interest in machine learning, and I was able to figure out these things because of the library that we built. It also comes with various debugging tools that make it easy for you to know what's going wrong. If you need to change the neural network or change the learning algorithm in order to make it work better in your game, the tools we give you help you figure out what parts of the network aren't actually helping the agent learn and which parts are working well. Combining these tools with various visualizations will allow you to see how quickly your bots are learning and what you can do to improve their performance. If you're interested in this machine learning library, please go to Strife AI and sign up for our closed beta, where we'll share the machine learning library with you so that we can get feedback on how to make it even better for game developers. Thank you for watching this talk, and I hope it taught you about machine learning and gave you some hope for a future where AI can suck much less. I love to teach people about machine learning, especially in how they work in games, as I've wanted this for the last 10 years of my life. If you're interested in learning more, feel free to reach out to me at Brendan@Strife AI, or you can connect with me on Twitter at RobotBrendan. Thanks so much, and I hope you have a great rest of your GDEX.
Welcome back.
Welcome back. That was pretty interesting.
Yeah, there was a lot of cool
Awesome.
stuff in there. So we're gonna pull Brendan in here and chat with him. We got a couple questions from the audience, and I think Caleb, you got a couple things you wrote down.
Yeah, I want to know if he is Mr. Incredible's arch nemesis and if he programmed the robot. That's top of my list.
Brandon, you with us?
Hey, how's it going?
Good. Thanks for talk, man.
Yeah.
Thanks. Yeah, I put some time into it, so I'm glad you guys liked it.
Well, I appreciate it. Caleb, you want to start? And we got a couple audience
Yeah,
questions.
so I have a bundle of questions just myself because I find this kind of stuff really interesting. You probably saw a couple of the questions in chat because I know you've been in chat. One of the things I wanted to ask first off was, what kind of implications do you see machine learning having for all the different genres of games? So, like, which genre do you think first is going to benefit from machine learning if it's implemented, and then which one's going to benefit the most?
Yeah, so the place that we're kind of thinking right now are games that are kind of like roguelikes tend to work well since a lot of the game is procedurally generated and very kind of different. It's interesting to, for example, train characters and then see how they interact in this completely new world. That way you know that they're doing something that they've never actually done before. They're doing it based on what they learned, and they're not doing it based off of something that they like memorized. So I think that's really exciting. Kind of shows how, they're really learning how the world works, and they're not just copying what you're doing.
Yeah.
So we got a question. How does the ML agent make observations in the game environment?
Yeah, so I'll talk about how our game does it, and then I can also talk about how you could do it. But in our game in particular, there's basically a small grid around the character that contains like the tile map. So it basically shows like these areas are free, these areas contain platforms or contain like the conveyor belts or whatever. And so we basically take like that very low resolution version of the game world and tie that into the actions that you're taking in order for it to basically like learn, oh, when I see, a flat area and then a ledge and then another flat area, that's something I need to like jump at this moment. You can do all kinds of things though. Some of the other games we did like ray tracing, where basically you just shoot out a ray and report back what is at the end of that ray in terms of, is it an enemy, is it a projectile, is it a wall? And then you also can report like the distance. So you can say like, there's a wall like 10 feet in front of you, or a wall 5 feet in front of you. You can also do things like omniscience, where the bot can just know, like, I just know that I have 100 gold. Some of those things I try to avoid doing though, because they make it not very, they make it not scale well. Like if the bot learns like some magical thing is happening over in this part of the world, and then you go to a different game world, now that bot is kind of like pre-learned something that's no longer relevant in this new level, if that makes sense.
Yeah.
So tons of different ways you can put, data into your character. The thing that I found works best is picture how you play the game and then try to give the same information to the bot.
Okay, just quickly, we have a question. You mentioned 3 types of ML, but the person didn't recall you talking about the third. Do you know what that was? Remember what that was?
So the 3 were reinforcement learning, preference learning, and then imitation learning.
Okay.
So reinforcement learning is kind of like that reward system that's sort of like you give the dog a treat when it does, something good, and it will keep doing that good thing. The second one is that preference learning, where you kind of pick, like, you watch the bot do something, and then you say whether or not you liked that. So it's kind of like getting feedback. And then the third one is the demonstration-based thing that I showed you guys, where you give a demonstration, and then the bot will try to copy that demonstration. So those are kind of the 3 different types.
Sweet. Did you have another question? We got a bunch from here. So.
Yeah, I mean, we can just keep going with chat
You
questions.
want me to just keep going?
Well, you mentioned 2 left. We got 2 questions, so mine will be real quick. What kind of personalization can we expect from machine learning? Like, how can the individual most expect to benefit in their gameplay or benefit from whatever game they're programming?
Yeah, so I mean, it depends on the type of game, but like what we're focused on is specifically like personalizing the behavior, right? So a lot of games on the market today, you can personalize like the appearance of your characters, where like maybe if a party member, I can choose like what armor they have, and I can like make them look, pretty sweet. But like you can't customize how they act. So we like the idea of, you give a demonstration for like some allies, and then they'll learn how to play like how you showed them to play. So we kind of have this idea of working on like a game like Pikmin, for example, where you have all these kind of like little minion guys, and you show them what you want them to do, and then they go and do it. But I mean, like, that's what we're focused on now. There's a ton of different ways you could use machine learning, as I alluded to.
Awesome. Cody, are we needing to kick to ads here?
No, I think we got time for one more.
One more.
One more? Okay.
Yeah.
So this one's, how did you land on a Steam description? Like, how do you communicate the coolness of what you're doing without it sounding like too techy or inaccessible?
Yeah. So what we actually did was we just hired a writer who doesn't know anything about the tech and had him just write it for us. That way, we're engineers, right? We're gonna go down into the rabbit hole and kind of geek out a little bit too much about machine learning. So we got someone else to basically write it for us, someone who has no idea. They're not even impressed by the machine learning necessarily unless it actually works. They're not impressed by just the technical details of it. So that was our strategy.
That's smart. That's smart. Where did you find this person?
I just knew him through like a friend of a friend.
Okay.
So I mean, and things like GDEX, right? You meet people at GDEX and find people to balance out your team or whatever. Maybe if it's only for just a small contract or something like that.
Awesome. Well, Brendan, we appreciate you being on, starting us off here on Saturday. Feel free if you want to hang around in the Twitch and the Discord, because we do have some questions, but that's up to you. But again, thank you, and hopefully we'll see you next year.
Yeah, thanks for having me on. And like I said, my username is Death Caliber on Discord. So if you want to just either DM me there, or I'll be in the public channels. So thanks a lot, and hope you guys have a good rest of your day.
Awesome. You too, man.
See you.